Oh, I hit start too early. Whoops. Oh, well. All right, so today we're going to be getting started on an 820-3437 that does not see a charger and does not turn on, and we're going to try to figure out why that is. I actually have a working Discord below. I'm not putting it into injecting the audio into the stream anymore because it was driving people nuts, understandably so. But I can actually now hear what you're saying via Bluetooth. So we'll see what a nightmare that becomes. Anyway, so let's just get on with it. Let's open up a schematic and a board view for this. And I don't take financial advice from John McAfee. Thank you very much for those who were suggesting that I do. It's one of those things that I would suggest you not do either. Make decisions for yourself, but not based on John McAfee. The guy that went from like 100 million to 4 million in a year or two. No. Okay, so we're going to get our board schematics up on the screen and go from there. Let's find it. Let's see. He won't start streaming until you buy a Quick. Correct. I'm actually interested in how that's going to go. I sent Dave Jones at EEV Blog a Quick a few weeks ago to take a look at and tell me if he thinks it's a piece of junk or not, since he gives very interesting critiques, and we'll see. So if we were to go over an older MacBook and how the charging circuit works on that, that would be a little bit helpful before getting into this one. I always try to assume that the people watching don't quite, are starting from scratch, so to speak, to make things easy. So let's go over this and see if we can make it make sense. Wrong. Yeah? Huh. Ah. Okay. Huh? Ha-ha. Okay, so let's go over how this works. Now, on the older machines, the way this would work is you have 18 volts coming in through the charger, but unlike a PC that just sees voltage and decides, go! On these machines, you need for the charger to talk to the computer, which happens on the adapter sense line. Now, adapter sense isn't going to go directly to the computer because adapter sense is a 3-volt signal, and it's sitting right next to this 18-volt signal on this magnetic adapter. And what do you think drunk people are going to do while they're trying to plug it in and, doing something like this? It's like, oh, my computer plugged, blah, blah, blah. They're going to send the 18 volts directly to the adapter sense line, which is going to blow up the computer. So because of drunk idiots, we have a one-wire circuit, which is set up like this. Adapter sense is going to go to U6900, and U6900 is going to separate external from internal. And it's going to keep 18 volts from going to our SMC, and in the case that a drunk idiot tries to plug in his MacBook after a night of being a drunk idiot. So, what do we need in order for that system to work? What do we need in order for U4900 to be able to talk to the charger? Well, we need U6900 over here to turn on. But U6900 is not going to turn on if it doesn't have voltage on pin 1, which is the VCC pin, which is what U6901 is for. U6901 is going to take our PP3V42 and it's going to send it over to this to power it on if SMC BCACOK is present. Now you've been wondering, Lewis, why are you going over this on an 820-3115 board when this is a 3437? The reason we're doing that is because if you take a quick look right over here, you will notice that we do no longer have those chips on the motherboard, which we do have a schematic for. Those chips are now sitting on the DCN board, which we don't have a schematic for. So up here, you'll see U6901, and under here, you'll find U6900. Now, in order for this to even work at all, even if those chips are doing their job, if our SMC is dead or not turning on, they won't work. So how do we determine if our SMC is turning on? Good question. To determine if U4900 is turning on, which is this thing over here. There. Come on, show up on the screen. Show up on the screen. U49. In order to determine if this thing's turning on, what you need to do is check the voltage on PP bus G3 hot. Why is that? Well, this chip communicates with a lot of different stuff. See this? bidirectional data line, bidirectional data line, bidirectional SM bus data line. It goes to a bunch of different things. And one of the things it goes to is U7000, which produces Pepe Bus G3 hot. See, this chip takes U7000, takes voltage in from the charger, and shoots it out to the system. Now, it decides what voltage it's going to produce at first based on a pull-up resistor that's going to sit on the charger cell line. If you pull it up to around 3.42 volts, you get 12.6 volts, and that may not be exactly that because there's another resistor in line here. But if you pull it up to like 1 or 3 volts, you'll get 12.2 volts. Let's restate that. If you pull charger cell up to 1 to 3 volts, you'll get something like 12.2 volts. And if you don't pull it up at all, you'll get something like 8.1. However, once the SMC starts to communicate with it, you get a little bit of a higher voltage by about 2 to 3%. So if you're not getting that voltage kick up by 2 to 3% on this IC, which talks to the SMC, then your SMC is probably not on. And the way that I figured this out is every single time I would not have a green light, and I would get 8.1 or 12.2 volts on PP Bus G3 hot. Every time I did have a green light, I'd get 8.5 or 12.5 volts on PP Bus G3 hot. It's not like this is written in a manual. It's just this kind of pattern recognition. Important to learn how to recognize patterns over time. Let's check out our Pepe Bus G3 hot and see what we're getting. But first, before we do that, let's pray that this multimeter thing actually works, because B&K sucks and makes terrible, terrible, awful software. For a $160 meter. So we're just going to check on here, and oh, it's not working because it's crappy software. That's go B&K. Go B&K. So every time I open it, I'm not sure if you could even see this, but every time I open the software, it actually shows me the schematic because the software can't work alongside Open Broadcaster because it's a pile of crap. I'm going to try closing Open Broadcaster, reopening it. What a pile. All right, let's see if that does it. Let's turn this into RS-232 mode. You can do it. You can do it, you B&K pile. Huh? Come on, good piece of crap software. Am I an idiot? I thought that by upgrading from the $30 meter to the $160 meter that I get better software. Oh, that was dumb. Anyway, so first thing we're going to do is we're going to check out Pepe Bus G3 hot. So let's just open up our board view and our schematic, make them evenly sized to make viewing easy for me. Zoink. And Pepe Bus G3 hot. I typoed that terribly. But that's fine. Paul Daniels' beautiful software autocorrects us. Is that a 4K monitor you're using schematics on? Indeed. Audio is out of sync. Indeed it is. Indeed it is. Not much you can do about that. So I get to choose between sync or crackling. So, hey, wrong shortcut. All right. Out of sync or crackling, you get two choices until Open Broadcaster bug with VST plugins goes away. So let's check Pepe Bus G3 hot and see what we get. So it seems like we're getting 8.1 volts, which would tell me that the SMC is not turning on. Not turning on. So what we are going to do is see why that is. So what's going to turn the SMC on? One thing you may be noticing at this point, if you've been watching a lot of these videos, is that the signals called reset signals. They will keep things from turning on. So, let's see. Someone says audio is broken. Oh boy. Oh. Let's see. All right. So hopefully that fixes everything. I just restarted that lovely audio program I use. And let's see. So let's go back to the schematic here and check out. Oh, where was I? Ah, reset signal. So let's check out a reset signal here. So this IC is going to shoot out something called SMC reset L. And anytime somebody complains about out of sync audio, it's probably going to wind up crackling when I restart that program. So just deal with it. So SMC reset L over here, it needs to be high. Because if it's low, which is what underscore L over here is for, underscore L means the signal is present when it's low, underscore L means that the reset signal is present. So the SMC will be reset. Now I want this signal to be high. So let's search for where SMC reset L would be. SMC. What do you like about Apple products? Someone asks. For me, nothing particularly. Okay, so that's going to be present. Oh, let me rotate this so it matches. Is it just me or is this inverted? Uh-oh. Okay, there we go. Hit the wrong shortcut. What do you... Okay, so we're going to measure that over here. Let's check SMC reset. See if we get anything good. SMC reset is 1.8 millivolts. That's not volts, that's millivolts. So let me just change the range so that that doesn't trick you. See? 0. Nothing. So we're not getting SMC reset. So now the next thing that I would go for is checking if there's voltage on the other side of this pull-up resistor. And there is. Next thing we do is check the pull-up resistor. Now, before we do any type of tests of continuity, keep in mind that we're going to have to turn off the power. So I just turned off the power supply. And let's take a look. Hopefully there's something there. Let's see, crackling noise. Well, I'll have to figure that out after the stream. Can't really do that while I'm fixing a board, I'm afraid. Maybe I could play the video and see if there's anything that is noticeable here. Let's see. I do have my Bluetooth on, so I guess I could listen. I wonder if Time Warner would let me listen to my own stream. Like, I wonder if that's even remotely possible. Come on, YouTube, you can do it. YouTube app? Wanna work? Eh? Wanna load anything at all, actually? Here we go, let's see. Okay. So let's measure this resistor. All right, that says 85 kiloohms. Huh, stream sounds fine. All right, so that means that the people are just screwing with me at this point. I believe you when you said the audio didn't work before, but now I can't believe you because I'm listening to it and it works. Which means you must be screwing with me. Okay. So never stop what you're doing to fix something in the middle of a stream, because somebody's probably screwing with you. So it looks like this resistor is 88.8 kiloohms, and it says schematic says 100 kiloohms, which is close enough. Okay, so what do you do then? Well, it's not the pull-up resistor, because the pull-up resistor is measuring properly. And it's not the lack of voltage going into it, because we have 3.42 volts on the other side of the resistor. So it must be that this chip is pulling it down. But why is U 5110 pulling it down. I'll ask you, Tarman, next time. I can't trust the trolls in my chat for anything. Okay, so we check out U5110, which is on the other side of the board, situated right by the Wi-Fi chip. And let's take a look at that and see what we see. So is there anything here that anybody would deem suspect? Let's see what you all think. The pull-up resistor is nearly 20% out and rated for 5%. Ah, very good catch. That's a good point to go over here. So let's go over why I don't care about resistors that are lower in value versus higher. I think I hit the wrong shortcut again. Uh-oh. Schematic. Full screen. So let's take a look here. So the resistor says 100 kiloohms, yet it's measuring a value of 88.8K. The reason that I don't care about this is because when resistors fail, they typically fail up in value, not lower in value. So if a resistor is measuring lower, then that's not something that I care about. Even though it says 5%, that resistor may actually be exactly 100 kiloohms, but I'm still measuring 88K. And the reason is because I'm not just measuring the resistor when I'm measuring it in the circuit. I'm measuring the path that that resistor has through everything else. So, for example, this PP3V, I'm measuring between here, this point, over here, pin 3, and pin 5. So I'm not just measuring the path of the resistor, I'm also measuring the path between pin 3 and pin 5 inside the IC itself. And that's going to then create a parallel path, which is going to lower the resistance. I'm also measuring, keep in mind, this is between PP3V42 and SMC reset L. PP3V42 also goes to the SMC. And SMC reset L also goes to the SMC. So that means that I'm measuring the resistance between PP3V42 on U5000 and SMC reset L on U5000. Do keep in mind that SMC reset L also goes to U7100. And what else goes to U7100? PP3V42, which means that I'm also measuring the path between pin 12 and 13 through U7100. So there are several parallel paths that it can take. So I am going to expect the resistance to be lower than what I would usually get, but I wouldn't expect for it to be higher. I want to start my own business. Any tips? Please help. The first thing that you never want to do is please, bro. That's the worst thing that you could possibly do, which is please, bro. So like I have complicated, open-ended, confusing problem. Please provide answer in one sentence. That does not work. That doesn't work. And yeah, you can't really. And you posted the same question 3 times, so you got to go. Sorry, guy, you got to go. I can't. Bye-bye. So anyway, so we're going to check out this SMC reset LIC again, because as you can see in here, it doesn't look very nice. It's not that even that the IC doesn't look very nice, but there's something right over here that's troublesome to me. What's that? What's that? This is all it takes to kill a Mac. This right here, this is genuinely all it takes to kill a Mac. Look at that. Look at that. It's like I need to go 45x for you to even see that. You can barely even see that, but that is all it takes to kill a Mac. That's all you got to do. That little crap stain over there. I mean, let's see. Okay, just to give you an idea of what it takes to kill a Mac, I'm going to take this Q-tip over here, and I'm going to put this Q-tip, this is my hand, this is the Q-tip, next to the offending participle. So let's just put the overhead camera in view for just a quick moment so that you can watch as this happens. Watch as this comes to this on the screen. So we're going to do this. Okay. This is the Q-tip. Ready? You can't even see it because the Q-tip is about 4 times, like 10 times the size of whatever that is. But that little schmuck, that little piece of whatever right there, that's all it took, man. All right, so let's just... We're just going to knock you straight off. And the fan is spinning. the fan is going to spin. This model turns on, off, on, off, on, off, and then on. But as you can see, it works. And we also have a light on the charger. See? We have a light in the charger. And it's turning on, the fan is spinning, and it's a happy little computer. That's it. That's all it takes. It's like, whoop. I don't know if any of you guys remember the video that I did where I took almost a quart of water and I spilled it right into a ThinkPad while it was on. Prime 95 running, full CPU load, screen full brightness. Just poured it in there. Just kept chucking along, kept working, just kept working, just kept working. Came out little drainage holes in the bottom. This tiny little piece of glitter worth of something falls on there. A spider goes to the bathroom inside of your computer while you're sleeping. That's it for you, man. Okay, so let's just go over the which capacitor that was, because this is honest. This is kind of funny. This is kind of funny. Oh boy. So what happened here? So I knocked off C5101. C5101. Right over here. So the SMC manual reset most likely short-circuited to ground. SMC manual reset, which was causing this to reset. So since SMC manual reset was probably low due to a short to ground, it was doing that. That's about it. That's all it takes. That's all it takes. Surely it needs a complete circuit, if not the part replaced with an appropriate spare. Okay, am I going to replace it before I give it back to them? Sure. But for testing purposes, it's clearly not needed. It's not a critical capacitor. It's not in line with something. It's not a large bypass capacitor on a rail that needs stabilization. That's about it. Yep. So we may get on to another repair later today, but yep, that's all it takes. That's all it takes for that little $1,200 thing to be turned into a doorstep. If you value durability, are you going to buy a MacBook Air? That's what I thought. That's it for today, and as always, I hope you learned something.